Hello everyone and welcome back. Today we are going to discuss about a very fascinating story of our daily life. You must have got into this situation often during the rainy season. You must have noticed also that when you stand sometimes, then the rain appears to fall vertically on your head. But the moment you start running, the rain started falling on your face. Have you ever thought that what actually going behind it? What is the physics that is involved in it? Okay, so today we are just going to unwrap all these things before you, and it will be a fun session. I promise you that we are going to solve the mysteries of physics very easily, and at the same time it will help you to solve the problem that you face in IIT JEE and your NEET examination based on this concept. So the concept is the concept of relative velocity. Friends, just stay tuned. Friends, let's unwrap one more situation that you have noticed in our daily lives. That whenever you sit in some train and the train is stationary, and if you just look out of your window and if some train besides you starts moving, then you feel that it's you who is moving backward. So this is all a kind of a feeling, but your common sense lets you know that this is not the actual movement of yours. This is the movement of the train nearby. So it clears only one thing, that motion and rest are totally deceptive kind of thing. Until and unless you fix your frame of reference, that in what frame of reference you are actually deciding your motion or rest, in that case it is very difficult to pass a judgment that whether you are actually moving or you are actually at rest, because defining an absolute rest and absolute motion is virtually impossible until and unless you find definitely a fixed frame, because there has to be something in this world that has to be fixed. If you consider that you are on earth, but if you see from the sun, then your earth is also moving. So there is no absolute frame from where you can find a fixed sense of motion. Okay, but since our job is not to not to find out a fixed frame in reality, but to understand that in what frame of reference a particular judgment can be valid enough. Okay, so let's try to break down this concept mathematically and in a very simpler way, so that you can understand that what is the and how to approach whenever we are just facing this kind of problem in physics. So let's break down the physics underlying it. I have just drawn two figures, and we can see that I have just said there is a ground and there is a bus. Okay, both these have two frames. Okay, because whenever you are talking about frame, what does a frame mean? The frame means nothing but that can be anything that can be positioned with respect to time, that is a frame. Now each and every frame should have some kind of coordinates to decide your position. For example, this is the observer on the ground, and this I'm assuming that earth is at rest, and this is a bus. A man is just running or kicking on the bus. So if you see, this is the observer looking at this man, then we can see this is the position of this man with respect to ground. RMG is nothing but the position of man with respect to ground. Okay, now if the man similarly views at bus, then this would be the position of bus with respect to the ground. Okay, these are the two origins that I have shown for the ground and the bus, and these are the coordinate system for the bus and the ground frame. This is the ground frame and this is the bus frame. Okay, both are bus and man, both are moving, suppose, and this is nothing but the position of man with respect to bus. So this can be written as RMB. Now from the simple vector addition, you can see that both the vectors, all the vectors are in the same direction, so you can simply add it. If you just want to put a vector signs over it, you can put it also, but since I have written in bold, that means I am just taking this as a vector quantity. So these are all vectors. Okay, accelerations. Now we can write this RMG is nothing but the summation of RBG plus RMG. RMB. Okay, what is RMB? RMB is the position of man with respect to bus. Suppose all these things are moving. If the position is changing, that means what? That means say we are talking about a motion. If the position of an object change with respect to a time, with respect to a frame of reference, that means that particular body is in motion with respect to that frame of reference from where we are observing or passing our judgment. Okay. Now, if we just differentiate, if we just rate of change of position is what? Is the velocity. So, if we just differentiate, that is the dr by dt. If we just do the differentiation of dr by dt, what you are going to get? You are going to get the velocities. The velocities of man with respect to ground can be written as summation of velocity of man with respect to bus plus velocity of bus with respect to ground. Similarly, if there is a change in velocity, okay, if there is a change in velocity with respect to time, what does it mean? It means that there is an involvement of accelerations. I have touched all this topic in our frame of reference, and at the same time multiple numericals that I have posted in our playlist. You just go and watch them, and I hope that is also going to help you a lot now to get another perspective of solving the problem. So while differentiating the velocity, we are just getting the acceleration. Okay, now friends, you must be thinking that how this mathematics is going to help us. See, whenever we are just, let's take this two very simple example. We have seen that if two buses are approaching each other, suppose this is the bus number 1 and this is the bus number 2. If two buses are approaching each other, suppose this is coming with a 60 and this is also coming with 80. Then while crossing you feel that the velocity of the bus which is crossing you having the more velocity than yours. Okay, why it is so? Because there is also a kind of a that I have already told you, that anything that whenever you discuss about motion and rest, it is absolutely a elusive term. Okay, so you have to decide the motion with respect to a frame. Now I just draw this figure. There are two cars. Suppose this is a two cars A and B, and this is the earth. Earth is nothing but the ground. Then this could be the position vector of the car A with respect to earth, RAE, and this will be the position vector of car B with respect to earth, RBE. Now this is a triangle, and from the triangle rule of additions, what do you know? That this side, this is the vector, and this side would be the summation, would be the equal to this. So RBE can be written as RBE plus RAB can be written as RAE. So ultimately RAB will be nothing but equal to RAE minus RBE, and this what is shown over here also. So whenever you are just trying to find out the velocity of one car with respect to another car, that means ultimately what you are doing, you are just subtracting their positions or subtracting their velocities. Since this is a vector quantity, and you know all the vector quantity could have multiple directions. So if you are just dealing with an abstraction, then in that case you can write RABX. That means only the x coordinate has to be considered, RAEX, okay, and RBEX. Okay, similarly for the y and z you can emulate. Okay, similarly. Okay, so you must remember only one thing, that since you are dealing with a vector quantity, and every vector quantity has magnitude and directions, so magnitude portion is okay, that is the quantity of that particular physical quantity. But when you are just talking about the direction, then you should think that what kind of dimensions are involved here. Okay, now let us try to understand and let us try to bifurcate the everything with respect to a problem. So let's see the problem of the day based on the concept that we have learned just now. It is about the same man and the rain problem, but here it is something different than what we have started with. It is a question that a man is standing on a road and has to hold his umbrella at some angle 30 degrees. That means at this time everything is stationary. Okay, so this is actually the velocity of rain with respect to ground, because whenever there is nothing is mentioned that it at what frame of reference it is falling, that means it is clearly mentioned to you that you should take ground as your frame of reference. So this is the direction of rain with respect to ground for now. Okay, now same he throws the umbrella and it starts running at 10 km per hour. The man started running in this direction at 10 km per hour. And if he is running at 10 km per hour, then you can consider that this is nothing but the velocity of man with respect to ground. Okay, it is in x direction. If I'm just taking this as an x and this is an y, so you can say the velocity of man is in x direction and velocity of rain with respect to ground in between the x and y axis. Okay, this is VRG. Okay, and this is VMG. Then what he finds? He finds that rain is actually hitting his head vertically. That means this is the again the illusion of the rain appears to be falling with respect to the man. So this is nothing but the velocity of rain with respect to man. Now I just told you that, see, if we are just observing rain with respect to ground, then you can write, you just draw a ground frame. Suppose this is a rain frame and this is the man. So this is nothing but velocity of a position of man with respect to ground. So this could be written as VMG, can be written as V velocity of man with respect to velocity of, since you are observing rain and man, so let's make it like this. So you are observing rain, so let's make it like this. So velocity of man with respect to ground plus velocity of rain with respect to ground. So velocity of RG can be written as VM velocity of rain with respect to man plus velocity of man with respect to ground. Okay, so VRM can be written as VRG minus VMG. Okay, now let's try to understand. VRM is already given in the y direction. So whatever the component of velocity of rain with respect to man in this direction will be equal to velocity of rain with respect to man. Okay, so this, if from this triangle if I just show, then this is the base, so this will be the cos theta. So I can write VRM can be written as VRG cos 30 degree. And the velocity of rain with respect to ground in the perpendicular direction from this direction, that is the VRG sin 30, is nothing but the VMG. Okay, okay, because all these vectors are the same direction, having the same magnitudes, and now VRG can be written as what? VRG can be written as VMG by sin 30 degree, and sin 30 is nothing but a half, so this is equal to twice VMG. So if velocity of man is to 10, ground is 10 kmph, so this can be written as 20. Similarly, velocity of rain with respect to man can be written as what? VRM can be written as VMG. VRG is now 20, and cos 30 is nothing but root 3 by 2, that means 10 root 3. So this is the way that you should take all the problems of relative velocity. You just no need to get panic. Just use the concept. Just try to understand that what you are observing right now, and with the observation you just write your equation of the relative velocity, and it will be very easy. So friends, before I just signing off, I am just telling you one more time that whenever you are trying to solve the relative velocity problem, you just try to draw a figure like this. Okay, and with the base of this figure, you can try to understand, you can try to make out, it will be very helpful for you to make out things that are associated with the physical quantity that are asked in the question. Maybe sometime you will be asked on acceleration, maybe sometime you will be asked with respect to force, because because force is also dependent on what? Acceleration. So acceleration, if the acceleration is changing from frame to frame, that means the force, the appearance of force, the kind of a feeling of force from the different frame of reference is also going to change. Okay, so this is going to change at multiple places. So I'll be bringing more problems on the relative velocity so that your concept will be more solid. But for the time being, I'm just leaving you with one question for your curiosity, that whenever you are seeing the now rain and man problem is almost clear to you, you just tell me why the same thing doesn't happen when in case of sun rays. Suppose in afternoon you just go out with your umbrella, and if you start running, you never found that sun rays is hitting on your face now, when it was hitting vertically when you are standing. But if you just start running, it doesn't hit your face. You don't have to change the angle of your umbrella. Why that is so? And if you are able to solve this problem, please give your explanation in the comment box. I'll be happy to see I am happy to see that our subscribers, our viewers are actually participating and they are enjoying the world of physics. And at the same time, to the students, and they'll also this will strengthen your concept, and it will motivate us also to bring more inquisitive problem for you, so that your concept, your fear for physics completely went away, and there will be no way that you can't score a very good and high scoring marks in your examinations. So thank you friends, and have a great day.